Okay, imagine this. A game world that doesn't just look real, but actually, feels real, where every character you meet has their own personality, and the world itself changes based on what you do. Just like, well, real life. That's not some far-off sci-fi dream anymore, is it? I mean, the speed things are changing in game tech right now is it's just staggering. So today we're doing a deep dive. We're looking at the really big shifts happening in how games are made and played right now in 2024 and looking into 2025. Our mission, basically, is to unpack the breakthroughs that are changing games from the inside out, making them feel like something, yeah, straight out of the future. We've got some amazing source material to work from here.
It really is an exciting time. And what's so interesting now, I think, is that it's not just small steps forward, like slightly better graphics, maybe faster loading, that kind of thing. These are really foundational changes. They're reshaping pretty much every single layer of how games get made, from
Yeah.
the visuals, how light works, even down to how characters think and act in these incredibly rich worlds.
Right. So if we're talking about building these incredibly rich living worlds, our sources really point to Unreal Engine 5 as being, well, fundamental, like a central pillar for all this. It really seems like the bedrock. So let's start there. Nanite virtualized geometry. For someone like me, not building engines daily, how does this actually change the level of detail we see in games?
Yeah, great place to start. Nanite, a total game changer for detail. So traditionally, artists had to make multiple versions of a 3D model. Simpler ones for far away, more complex ones up close. LODs, levels of detail. It was a lot of manual work, and you'd often see things pop into higher detail as you got closer.
Oh, yeah, I know that poppin'.
Exactly. But Nanite, basically, it streams only the microscopic details your screen actually needs, right when it needs them. It's much smarter about it. So artists can take these film quality models, like from ZBrush or photogrammetry scans, super complex stuff,
Yeah.
and just drop them straight into the game.
Wow.
And they just work. They stay crisp. We're seeing reports, like scenes with 50 times more polygons than before.
50 times.
Yeah, 50x.
Yeah.
And still hitting that smooth 60 frames per second target on consoles. It's almost like infinite detail without the massive performance hit you'd expect.
That sounds, well, like a dream for artists, frankly. Yeah, no more tedious LOD work. And then there's Lumen, the fully dynamic global illumination and reflection system. What's Lumen doing that's so different from, the old way games handled light?
Ah, Lumen. Yeah, this big breakthrough is fully dynamic global illumination, or GI. So in the past, developers had to bake the lighting. They'd pre-calculate how light bounces around in a scene and essentially like paint that light onto the environment.
Right, light maps, static.
Exactly, static.
Yeah.
So if you moved a light source or the sun went down, the lighting wouldn't react naturally unless the developers did a whole new, often very long bake.
Which took forever, I hear.
It could, yeah. Lumen, though, it calculates infinite bounce global illumination every single frame.
Infinite bounces, every crime.
Yep. Light behaves like it does in the real world, bouncing naturally off surfaces, creating soft, realistic ambient light. And it's integrated with ray tracing, both hardware and software, for those sharp, specular reflections you see on shiny surfaces. So, inside buildings, the light changes naturally as the time of day shifts outside. Shadows update instantly. Everything just feels much more alive, more dynamic.
So, okay, scenario. I walk into a room, suddenly a monster smashes through the window, letting sunlight pour in.
Yeah.
The whole room's lighting would just instantly adjust realistically.
That's the idea.
Yeah.
Exactly. It sounds incredibly complex to calculate in real time, and it is, but that's what it achieves.
That's amazing.
And to make these huge, seamless open worlds possible, the ones that can handle all this complexity. Unreal Engine 5 also uses things like world partition, data layers, and virtual shadow maps.
Okay, break those down a bit.
Sure. World partition basically streams the world in just the parts around you as you move. So you don't have loading screens interrupting huge open worlds. Data layers let developers create different states for the same area, maybe a city that's flooded versus one that's dry, and switch between them smoothly.
Oh, interesting.
And virtual shadow maps. They make sure that even with all the incredible detail from Nanite, the shadows stay sharp and high resolution. No blocky or flickering shadows, even from super detailed objects far away. It all kind of works together to make these enormous immersive environments feel totally seamless and consistently detailed.
Something that always used to pull me out of games, even visually impressive ones, was the faces. Characters might look great, but their facial animation, sometimes wooden, or the eyes just felt dead. But our sources are highlighting MetaHuman Creator and MetaHuman Animator as a real leap forward here. What's the magic behind that?
It really is a leap. Yeah, MetaHuman Creator and Animator, they combine Epic's cloud-based rigging system with what they call a 4D facial solver.
4D, what's the fourth dimension there?
Time, essentially. It's not just capturing the 3D shape of a face, but how those shapes change over time with incredible detail and nuance. So it gets every tiny muscle twitch, every micro-expression, the real subtle stuff that conveys emotion.
Okay.
And the impact is just astonishing. They're saying it cuts down facial capture time from potentially weeks of work down to minutes.
Weeks to minutes.
That's the claim.
Yeah.
You can apparently use a single iPhone to drive Hollywood-level performance capture and retargeting right inside Unreal Engine 5.3 and newer versions.
That's an iPhone.
Yeah. It basically democratizes high-end performance capture. Suddenly, even smaller indie studios could potentially achieve character realism and emotional depth that used to need massive AAA budgets and specialized capture studios. It really shifts where the effort goes, you know? Less on the technical capture process, more on defining the character's actual performance and, well, soul.
That's amazing, that level of artistic freedom.
Wow. Okay, but all this incredible visual fidelity from UE5, Nanite, Lumen, MetaHuman, it sounds incredibly computationally expensive.
Yeah.
This is where, I guess, things like AI-powered frame generation and upscaling come in,
Right.
making photorealism actually, playable for normal people.
You're absolutely right. This is the crucial other half of the equation, the performance enabler. And yeah, we're mainly looking at three big players here: NVIDIA's DLSS, AMD's FSR, and Intel's XSS. Version 4 for DLSS, 3 for FSR, and 2 for XSS, roughly. Each one has a slightly different approach, a different technical underpinning, but the goal is the same: give you more frames per second without needing a, ridiculously powerful GPU, or letting you push visuals higher on the GPU you have.
So let's take NVIDIA first, DLSS 4.
Okay, so NVIDIA DLSS 4, specifically the multi-frame generation part. It can generate up to 3 extra AI frames for every single frame the GPU actually renders traditionally.
3 AI frames for every real one. Up to 3, yeah. It's a massive potential uplift. They're talking up to 8 times the frame rate in some cases on their newest RTX 50 series GPUs. Now, generating frames like that can add a little bit of input latency, a slight delay,
Ah, okay. The downside.
but NVIDIA uses their reflex technology alongside it, which is specifically designed to reduce system latency, so the overall feel is still very responsive. Cyberpunk 2077's overdrive mode is a great example where this tech really shines.
Okay, makes sense. And what about AMD's approach with FSR3?
AMD's FSR3, which stands for Fidelity FX Super Resolution, and its frame generation component called Fluid Motion Frames, is really notable because it's open source.
Open source meaning?
Meaning it's not locked to just AMD hardware. It can work on NVIDIA and even Intel GPUs. It can also sometimes work at the driver level, meaning you might be able to turn it on for games that don't explicitly support it in their settings menu.
Oh, interesting. Wider compatibility.
Much wider compatibility, yeah.
Yeah.
Performance-wise, it typically offers around a 2x frame rate uplift compared to just using FSR2's upscaling. The quality of the generated frames, especially how it handles motion, maybe isn't quite as refined as DLSS in some comparisons, but that broad compatibility is huge. Immortals of Avium was one of the first big showcases for FSR3.
Right. And Intel, they have XSS2. How does that fit into the picture?
Intel's XSS2 combines their AI-based upscaling with frame generation. It's optimized naturally for their own ARC GPUs like the B580 and B570, and also some of their core ultra laptop chips. They're really focusing on achieving low latency alongside the frame rate boost. We've seen figures like up to 4x frame rate improvements in games like Diablo 4 on their hardware.
4 times is significant.
It is. The main catch is that it uses a closed binary SDK, so developers have to integrate it specifically, and it works best on Intel hardware. But it's definitely a strong contender, especially if you're running an Intel-based system.
Gotcha. And you mentioned these are all 1440p benchmarks.
Yeah, it's important to remember the context.
Yeah.
Most of those big uplift numbers we see quoted are typically based on internal 1440p testing by the vendors themselves. Your mileage may vary, of course.
Of course. So beyond just giving players smoother gameplay or letting them crank up settings, why are these frame generation techs such a big deal for the developers themselves? What does it unlock for them?
Well, several key things. Firstly, it lets them target much higher visual fidelity in the first place. Think about real-time path tracing, which we should definitely get into. It's incredibly demanding. But if frame generation can take a game that's natively rendering at, say, a struggling 30 frames per second and boost that output to a smooth 120 frames per second, suddenly that super expensive rendering technique becomes viable, playable.
It opens the door to things that were impossible before.
Exactly. Secondly, there's the cross-vendor aspect, especially with FSR3 being open. For PC developers dealing with a huge range of hardware, having a single open fallback option for frame generation that works on NVIDIA, AMD, and Intel GPUs. That simplifies things massively for PC ports.
One implementation to cover most bases.
Pretty much. And third, and this is really crucial, frame generation provides significant CPU relief.
CPU relief, how so?
Well, in a lot of modern games, especially big open worlds with lots of simulation, complex AI, tons of objects, the CPU can actually become the bottleneck. It struggles to feed the GPU fast enough.
Right, I've heard of being CPU bound.
Exactly.
Yeah.
Since frame generation happens mostly on the GPU as a post-process after the main rendering work is done, it doesn't add much extra load onto the CPU. It effectively bypasses that CPU bottleneck. This frees up the CPU to handle more complex AI, better physics, more intricate gameplay systems, leading to a richer, smoother overall experience, not just higher FPS.
That makes a lot of sense. Freeing up the CPU for other cool stuff. Okay, so FrameGen gives us the performance headroom. Now let's talk about what developers do with that headroom. You mentioned path tracing. This is like the holy grail of lighting simulation, right? Stuff we used to only see in pre-rendered movies, now potentially running in real time in games. What's the leap from the ray tracing we've had for a few years to full path tracing?
It is a huge leap, yeah. Think that the ray tracing we've had so far is selective. Maybe it simulates one or two light bounces for reflections or gives you more accurate shadows. It's good, a big step up from rasterization. But full path tracing, it aims to simulate the entire journey of light. It traces rays from the camera, sees what they hit, then traces new rays as that light bounces off surfaces again and again, potentially infinitely picking up color and intensity until it reaches a light source. It's literally trying to simulate the physics of light transport, the whole equation. This is how light actually works in the real world. And the result is just mind-blowing realism.
Yeah.
Global illumination is inherently perfect. Soft area shadows emerge naturally. You get effects like true mirrored caustics, those shimmering light patterns on the bottom of a pool, for example, things that are incredibly hard or impossible to fake convincingly with older methods.
And we're actually seeing this, like, playable in games now, not just tech demos.
We are. Cyberpunk 2077's Overdrive mode is probably the most famous example right now. It uses full path tracing for pretty much all its lighting. You get that beautiful global illumination, the super soft shadows, those true caustics. And thanks to DLSS4 frame generation, it's reportedly playable at 60 frames per second on something like an RTX 5090.
Playable full path tracing in a massive open world. That's wild.
It is. And it's not just Cyberpunk. We've seen research demos showing things like 7,000 dynamic lights interacting realistically at real time, even on older hardware. That hints at possibilities for, say, incredibly dense neon cityscapes where every light contributes naturally without needing old tricks like manually placed light probes. And for developers, UE5 even offers a path tracing renderer they can just toggle on, maybe for cinematics or for in-game photo modes, so they can get that offline movie quality lighting look directly in the engine. It really blurs the lines.
Okay, so we've got worlds that look photoreal, almost like movie sets, with light behaving perfectly. Incredible. But what about the people, the characters in these worlds? Our sources suggest something pretty profound is happening with NPCs, non-player characters, moving them away from just being, pre-scripted extras, towards being genuinely dynamic conversational actors, driven by generative AI.
This is where things get potentially revolutionary for immersion and storytelling. Yeah. NVIDIA AC, that's Autonomous Character Engine, is a big name here. It's not just one thing. It's more like a suite of technologies bundled together. You've got speech to text, so the NPC can understand what the player says.
Okay.
Small, efficient language models running locally or in the cloud to generate dialogue on the fly. Audio two-phase technology for generating realistic lip sync automatically. And even situational planners to give the NPC context about the game world and the conversation.
So it knows what's going on around it.
To some extent, yeah. And the result, the benefit they're touting, is pretty amazing. They claim it can take a standard basic NPC and turn them into a fully conversational character in less than an hour of setup.
Under an hour for a talking NPC.
That's the pitch. Imagine talking to a random shopkeeper, and instead of hearing one of 3 canned lines, you have an actual unique conversation. The potential for emergent gameplay and storytelling is just immense. Yeah.
That absolutely sounds like it would radically change how you interact with game worlds. No more just clicking through dialogue trees.
Exactly. And there are other players too. In-World AI has their character engine. It provides what they call a drop-in character brain. It includes things like a contextual memory mesh, so the NPC can actually remember past interactions with you.
It remembers you.
Potentially, yeah. And real-time emotion layers, so its responses and even its animations can reflect its mood. For developers, this means instead of writing literally thousands of lines of repetitive bark dialogue.
Barks being those little phrases NPCs shout, "Stop right there, criminal scum."
Exactly. Instead of writing all that, designers can focus on higher level things, tweaking personality sliders, defining the character's knowledge, goals, relationships, and letting the AI handle more of the specific conversational flow.
More natural, less robotic character.
That's the goal. And we've actually seen a concrete example of this from a major studio, haven't we?
Yeah, Ubisoft.
Right. Ubisoft's Paris R&D team showed off their NEO NPC prototype. They actually combined in-worlds language models, NVIDIA's Audio Two-Phase for the animation, and crucially, their own custom guardrails.
Guardrails to keep the AI in check.
Presumably, yeah, to ensure the characters stay in-world, don't say inappropriate things, aligned with the game's lore, that sort of thing. Anyway, they created these two characters belonging to different factions, and the really cool part, they said these characters could have unscripted conversations with each other, and based on those chats and player interactions, could dynamically generate new quest lines on the fly.
Wow, quests emerging from NPC conversations. That immediately brings up questions, though. How does
Yeah.
this totally change game development? Especially for things like, writing the story or testing the game.
Oh, the implications are massive,
Yeah.
huge. Take narrative design. If quests can emerge dynamically, then traditional branching narratives, which already get complex, become less like trees and more like these sprawling, unpredictable webs.
Harder to map out.
Much harder. And think about quality assurance, QA. How do you test that? You can't just follow a script. QA teams will need new tools, probably AI-driven themselves, to run thousands of simulations, testing probabilistic outcomes, trying to find edge cases where the story breaks or the AI goes off the rails.
That sounds like a whole new challenge for QA.
It absolutely is. And then there's localization,
Mm.
translating games into different languages.
Yeah, that's already a huge task.
Right now, yeah.
Yeah.
But imagine combining these large language models, which are getting really good at translation, with real-time speech synthesis AI voices. You could, potentially, have games ship on day one, globally, in maybe 30-plus languages, all fully voiced and localized, with the AI handling both the translation and the voice generation.
30 languages on day one. That would be revolutionary for accessibility.
It would completely upend the current localization model.
Yeah.
Everyone gets the same rich experience simultaneously.
And what about the writers? Are they out of a job, or does their role just change?
I think it fundamentally changes. They shift from writing every single line of dialogue, which can be incredibly tedious for large casts, towards more high-level tasks. Things like prompt engineering, crafting the right instructions for the AI, curating the character's memories and knowledge base, defining their personality, motivations, biases. Essentially, they become architects of character identity, letting the AI handle the moment-to-moment conversational generation based on those foundations.
So more like guiding the AI than writing every word. Interesting. This AI wave doesn't stop with characters, though, does it? AI is also turbocharging procedural content generation, PCG. Now, PCG isn't new. Games like Minecraft or No Man's Sky have used it for ages to build worlds. But machine learning is making it much smarter, right? More coherent.
Precisely. Traditional PCG could sometimes feel a bit random or repetitive. Machine learning adds a layer of intelligence, learning from real-world data or artistic examples to generate content that feels more natural, more believable, and more aligned with specific goals.
So what are some key applications?
Well, one big area is terrain and biome generation. We're seeing neural networks, particularly generative adversarial networks or GANs, being trained on huge data sets, sometimes even real satellite imagery. These AI models can then generate incredibly realistic and varied landscapes, mountain ranges, rivers, forests, that not only look natural, but can also be guided to fit gameplay requirements, like ensuring there are enough flat areas for building or specific resource distributions.
So landscapes that look real and play well. No more weirdly placed mountains blocking everything.
Hopefully. Another exciting area is quest synthesis. Imagine an AI that looks at your playstyle, what kinds of quests you've enjoyed, what your current goals are, and then crafts bespoke missions just for you.
A personalized quest generator.
Exactly. With appropriate pacing, difficulty curves, maybe even tailored loot drops, it can make replayability almost infinite.
That sounds incredible.
And then there's asset generation, things like texture GANs or mesh diffusion models. These can be trained on a game's specific art style.
Trained on the art direct.
Yeah, using things like embeddings that capture the essence of the style. The AI can then generate new textures or even simple 3D models props, environmental clutter that perfectly match that established look and feel. This can massively accelerate building out huge libraries of game assets. It's a particularly big deal for smaller indie teams, giving them access to vast amounts of high-quality, art-consistent content without needing a giant art department.
It sounds like the tools and pipelines behind the scenes, how developers actually build games, are changing just as fundamentally as the player experience. What are some of those big shifts happening for dev teams?
Oh, absolutely. The way games are made is transforming. One major trend is the move towards cloud-native collaboration.
Meaning working in the cloud.
Essentially, yeah. Instead of everyone needing powerful local machines and constantly syncing huge project files, teams can work on streamed editor sessions. Think using tools like Perforce for version control, combined with pixel streaming tech, or cloud platforms like Amazon Lumberyard's cloud offering. The big advantage is that you can have teams distributed all over the world, all working together inside the exact same up-to-date version of the game map or level, without being limited by their individual hardware specs or slow downloads. It enables much more fluid, simultaneous iteration.
That sounds way more efficient for large global teams. Okay, what about those annoying hitches or stutters you sometimes get in games, especially when loading a new area? Anything helping with that?
Ah, yes, shader compilation stutter. That's been a persistent headache, especially with Unreal Engine 4 and 5. It can really break the immersion when the game freezes for a split second. Epic has introduced a new system called the Shader Pipeline Cache. It aims to mitigate this by pre-compiling more of the necessary shaders when the game is actually built by the developers, rather than compiling them on the fly the first time the player encounters them. It should lead to a much smoother experience, fewer of those jarring hiccups. It's one of those smaller, under-the-hood changes that makes a big difference to quality of life.
Good to hear.
And connecting this back to the hardware side, we're seeing dedicated silicon, actual hardware blocks for frame generation becoming standard. These optical flow accelerators, specialized units for analyzing motion between frames, which is key for good frame gen, they're now present across the board. NVIDIA's Ada Lovelace, AMD's RDNA 3, Intel's Battlemage GPUs, they all have them.
So the hardware is being built specifically for this now.
Exactly. It signals that frame generation isn't just a niche software trick anymore. It's becoming a core hardware-accelerated feature. And alongside that, you have technologies like PCI 5 providing massive bandwidth, combined with GPU-based asset decompression. Think resizable BiRR or AMD's Smart Access Memory, but taken further. This allows technologies like Nanite, which we talked about earlier, to stream potentially terabytes of geometry data directly to the GPU with very little CPU involvement.
Feeding the beast directly.
Pretty much. Minimizing CPU overhead for getting all that complex data where it needs to go, fast. It's another piece enabling these incredibly detailed, seamless worlds.
Okay, so we've covered this amazing wave of technology, incredible visuals, dynamic lighting, smarter characters, smarter world generation, better pipelines. But what does this actually mean for the game studios trying to make games in this new era? It sounds like both huge opportunities and maybe some serious challenges.
Absolutely, it's a double-edged sword in some ways. Let's talk budget and team structure first. On one hand, the baseline expectation for visual fidelity is definitely rising. These tools enable incredible realism, which can make it harder for smaller teams to compete purely on graphics if they're doing everything traditionally.
The bar is higher.
The bar is higher, yes. But on the other hand, many of these same tools, MetaHuman for characters, Quixel Megascans for environmental assets, these generative AI tools for textures or props, they can dramatically reduce the amount of manual art labor needed. So a smaller team, by cleverly leveraging these tools, could potentially achieve a higher visual standard than was ever possible before, maybe even competing with much larger teams. It compresses the required art man-hours.
So smaller teams can punch above their weight if they adapt.
Exactly. And it also means roles might shift. We mentioned writers moving towards prompt engineering and persona curation for AI and PCs rather than just writing barks. You might see similar shifts in art departments, maybe more focus on art direction and AI curation, less on individual asset modeling for generic items.
It's interesting. What about testing these games, though? You touched on QA for emergent narratives, but it sounds like a broader challenge. And are there ethical concerns?
Definitely major considerations there. QA for emergent AI systems is a big one. Because the AI's behavior isn't fully predictable, you need, as we said, probabilistic testing. Tools that can run countless simulations to try and find bugs or, crucially, unintended harmful or toxic outputs.
Toxicity filters become essential.
Absolutely essential. You need robust guardrails to prevent the AI from generating offensive, biased, or just plain weird content that breaks the game's tone or player experience. And then there are the ethical and legal dimensions, especially around privacy. If you have AI NPCs that players can talk to using their voice, those voice snippets might be sent to the cloud for processing by large language models.
Ah, data privacy.
Exactly. That immediately triggers concerns under regulations like GDPR in Europe or CCPA in California. Studios need to be incredibly careful and transparent about how player voice data is collected, stored, processed, and secured. It adds a whole new layer of compliance work.
A lot for studios to navigate. Okay, looking ahead then, 2025, 2026 seem poised to be when we really see games built from the ground up with this tech. What are some specific upcoming titles that our listeners should keep an eye on, ones that are expected to showcase these innovations?
Yeah, it's going to be a really exciting couple of years for releases. CD Projekt Red's next Witcher game, let's call it The Witcher Thief for now, is a big one. Slated for late 2026, built on Unreal Engine 5.6. They're promising things like path-traced interiors and using nanite for incredibly detailed creatures and environments. That should be a visual benchmark.
Witcher 4 on UE5, that'll be something.
Definitely. Then there's Ninja Theory's Hellblade II, Senua's Saga, expected maybe Q3 2025. We know they're using MetaHuman Animator heavily for those hyper-realistic facial expressions, and they're targeting full path tracing with DLSS 4. Expect that one to be a real showcase for character realism and atmospheric lighting.
Hellblade always pushes visual boundaries.
They do. And for just sheer density and detail, keep an eye on Black Myth. Wukong from Game Science. That's targeting Q2 2025. The trailers look stunning. Incredibly dense nanite vegetation, Lumen GI, and they'll be using DLSS 4 frame generation. It looks technically astounding.
Black Myth does look incredible. Any others?
Well, Ubisoft's Assassin's Creed. Shadows, the one set in Japan, due Q1 2026. That's expected to feature those Neo-NPC dynamic side quests we talked about, really leaning into emergent AI narrative. And it'll likely use AMD's FSR3 frame generation widely, given Ubisoft's partnerships.
Assassin's Creed with smarter NPCs. Interesting.
And maybe something a bit different. For Axis's Civilization David, anticipated for Q2 2026. They'll probably leverage Intel's XSS2 frame generation, but also potentially those procedural gens for generating more realistic and varied continents, showing AI's impact beyond just graphics.
Civ Deem using AI World Gen. Cool, so quite a diverse lineup showing off different facets of this tech.
Exactly. It's not just one thing. It's a whole suite of technologies coming together across different genres and studios.
So let's bring it all together. When you boil it all down, what does this wave of innovation truly mean for you, the player, sitting down with your controller or keyboard in the next couple of years?
I think you can expect game worlds that, yes, look astonishingly close to film CGI, but more importantly, feel more alive and reactive than ever before. Almost like stepping into a really sophisticated dynamic simulation or like a tabletop RPG session run by an incredibly advanced AI dungeon master. Light will bounce realistically off every surface. NPCs might actually remember that sarcastic comment you made hours ago and bring it up later. And thanks to AI upscaling and frame generation, you'll hopefully get to experience all this with smooth performance, even if you don't have the absolute latest, most expensive hardware.
So deeper immersion, more believable worlds, better performance. Sounds like a win-win-win.
That's the promise. It should feel fundamentally different, less static, more responsive, more personal.
And flipping that coin, what about for the developers? What's the big picture takeaway for the people actually making these games?
For developers, I'd say the creative possibilities have never been greater. The ceiling has been raised dramatically, but also the toolkit has expanded. Artists can push visual boundaries further or focus more on unique art styles, letting AI assist with some of the grunt work. Writers can craft deeper lore and more complex character relationships, relying on AI for more dynamic dialogue expression. Engineers can focus on novel gameplay systems, knowing the engine and AI can handle more of the underlying complexity. But it also means adapting. Studios that really learn how to integrate these AI tools, master these new prompt-driven workflows, and understand how to optimize for cross-vendor performance tech like DLSS, FSR, and XSS, they're going to be able to create experiences that are simply leagues ahead.
And those who don't adapt.
Honestly. Those clinging solely to older legacy pipelines might find it very difficult to keep pace. The potential efficiency gains and the sheer level of fidelity and dynamism these new approaches offer. It feels like a genuine paradigm shift. They might get left behind, frankly, because ultimately these converging technologies, nanite, lumen, path tracing, generative AI for NPCs and content, cloud pipelines, frame generation, they aren't just small incremental upgrades. They represent truly foundational shifts in how digital worlds and their inhabitants are conceived, built, rendered, and interacted with. Geometry, light, motion, dialogue, even the flow of the story itself. It's all being fundamentally reframed through the lens of real-time computation and artificial intelligence.
And the end result, for all of us playing these games, it sounds like we're heading towards worlds that feel meticulously handcrafted in their detail and artistry, yet potentially boundless in their reactivity and emergent possibilities. Worlds where maybe every single rock, every overheard rumor, every ray of sunlight genuinely contributes to the story, and where every playthrough feels uniquely yours, shaped by your choices and the world's dynamic response. It's an incredibly exciting future to contemplate. Definitely gives us all something to think about as we wait for these next generation experiences to arrive.